FastMCP2 employs dependency injection as its core mechanism for runtime value resolution, allowing tools to declare dependencies through parameter defaults without exposing them in the MCP schema. This design maintains clean function signatures while providing access to server instances and other runtime context. We're about to examine how a FastMCP server instance is initialized and how a tool function declares its dependency on that instance using the CurrentFastMCP injector. The code demonstrates the server creation pattern and the dependency injection set up for accessing server metadata within tool implementations. From FastMCP, import FastMCP. From FastMCP dependencies, import CurrentFastMCP. MCP equals FastMCP demo. At MCP, tool. Async def server info server. FastMCP equals CurrentFastMCP, SDR. Return F server, server name. This code demonstrates FastMCP's dependency injection system for accessing the server instance within tools. The pattern uses CurrentFastMCP as a default parameter value, which is a built-in dependency that resolves to the active FastMCP server instance at runtime. This approach keeps the tool's signature clean while providing access to server-level configuration and introspection capabilities. The mechanism works by declaring server. FastMCP equals CurrentFastMCP as a parameter, where CurrentFastMCP acts as a dependency marker. When the tool executes, FastMCP automatically injects the server instance, allowing the tool to access properties like server name. This is particularly useful for tools that need server metadata or configuration without hard-coding values. The trade-off here is between explicitness and convenience. Using CurrentFastMCP makes the dependency visible in the signature, which can be clearer than relying solely on type annotations. However, it does add a slight runtime resolution overhead. This pattern is ideal when tools need server context, but shouldn't expose that requirement to clients, as the dependency is automatically excluded from the MCP schema. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core functionality for implementing Model Context Protocol (MCP) servers. This import alone doesn't create any instances or configure behavior. It simply makes the FastMCP class available for use in the current namespace. From FastMCP dependencies, import CurrentFastMCP. Imports the CurrentFastMCP class from the FastMCP dependencies module, which provides access to the CurrentFastMCP instance in the application context. This is typically used for dependency injection to retrieve the active FastMCP server instance when needed within the codebase. MCP equals FastMCP demo. Creates an instance of FastMCP with the server identifier demo. The string parameter serves as a label for the server that will appear in MCP protocol handshakes, allowing clients to identify this specific server instance. This line initializes the FastMCP object, but doesn't configure any operational behavior or functional settings. At MCP, tool. Async def server info server. FastMCP equals CurrentFastMCP, SDR. Defines an asynchronous function named serverinfo decorated with @MCP tool, making it a registered tool in the FastMCP framework. The function takes a single parameter, server of type FastMCP, which defaults to the current FastMCP instance via CurrentFastMCP. The function is declared to return a string, indicating it will provide server information in text format. The decorator handles tool registration, using the function name as the tool identifier and automatically generating metadata like description and input schema from the function signature.
Return fserver, server name.
Returns a formatted string containing the server's name, prefixed with server, for display or logging purposes. The string uses an f-string to interpolate the server name attribute directly into the output. FastMCP2's dependency injection system elegantly bridges the gap between clean function signatures and runtime context access. By using CurrentFastMCP as a default parameter value, tools like serverinf maintain simple interfaces while gaining automatic access to the server instance. The @MCP tool decorator handles registration and schema generation, while the dependency injection mechanism resolves the server instance at runtime. This pattern keeps the MCP schema clean by excluding internal dependencies from client-facing interfaces, though it introduces minimal runtime overhead. The trade-off between explicitness and convenience is well balanced here. The dependency is visible in the signature, but doesn't clutter the protocol schema, making it ideal for tools needing server context without exposing that requirement to clients.
The function whispers its name to the decorator, who then shouts it to the void as a tool.